Okay, in this video we're going to introduce the concept of a Pythagorean triplet. And a Pythagorean triplet is based on an observation you can make by testing out the Pythagorean theorem on different triangles. The question basically is, when do we get nice whole numbers for the hypotenuse? When does this actually happen? Because a lot of times you'll notice, even with simple triangles like a 1 by 1, you don't get a nice hypotenuse, right? If I just do a quick sketch over here, if I have a 1 by 1 triangle, how long is that hypotenuse? How do I figure that out? Well, using the Pythagorean theorem, we could say 1 squared plus 1 squared equals c squared. And 1 squared plus 1 squared is just 2. Now that equals c squared. And you're tempted to think that this length here is 2, but it's not. That 2 squared is the length of a square of the hypotenuse with an area of 2. So this side length, this hypotenuse, is the side length of that square. In other words, c equals the square root of 2, which is a decimal, about 1.41. So it's not a nice number. So when does it actually work out in nice ways? The first triplet you probably come across, even if you haven't named it as such, is a 3, 4, well, the other side should be what? Using the Pythagorean theorem, we can say 3 squared plus 4 squared equals c squared. 3 squared is 9, 4 squared is 16. Add them up, we get 25. Now 25 equals c squared, and c equals the square root of 25. So c is 5, and this is a basic Pythagorean theorem approach. So here it's 5. So this is called, and this is one of our most famous triplets, the 3, 4, 5 triangle. It's so nice because all the sides are whole numbers, and also nice because all the sides are simple numbers, 3, 4, and 5. Now the 3, 4, 5 is called a primitive triplet. Now there are an infinite number of primitive triplets, and we can generate them using a formula that Euclid gave us, and at least I think he gave it to us, and I'll go over that in another video. But here I just want to talk about what it really means to say something's a triplet and how to use this to your advantage. Well, the 3, 4, 5 triplet is primitive because you can use it to generate other triplets. Let me clear this off right here. So let's say I have a 3, 4, 5 triangle. I know then that if I double everything, let's say to a 6, 8, 10, that's another triplet. Now this is not primitive because it's based on the 3, 4, 5. What I did was double each side length, and that gave me the next triangle. If I was to triple each side length, I get a 9, 12, 15. This is also a triplet with beautiful whole numbers there, but it's based again on the primitive triplet up here, and I can keep going. I can even go crazy. Let's say I multiply it by 100. I know a 300, 400, 500 right triangle is based on a 3, 4, 5, and it's a nice triplet. Now, how can I use this to my advantage? Well, there are many ways. But, I mean, if I gave you, a triangle that was 300 by 400, and then I asked you for the other side, there's a couple of ways to go about it. You could use the Pythagorean theorem to solve, or you can try and recognize if it goes back to a basic triplet. Because then, if you can do that, you can use what you know about the triplet to solve the question. Let me show you what I mean. So let's say I had the scale factor of 100, and by scale factor I just mean the number you're multiplying each side by from the original triplet. So here, to go from 3, 4, 5 to 300, 400, 500, I'm multiplying each side by 100. That's the scale factor. I multiply by 100. So the scale factor would then be 100. Just for that one case. Right, to go from 3, 4, 5 to 6, 8, 10, what's the scale factor? Well, it's 2 because I double each side. To go from 3, 4, 5 to 9, 12, 15, scale factor is 3 because I triple each side. How could I use it to my advantage? Well, if I gave you a 300, 400, and then asked you for the hypotenuse, instead of having to square 300, square 400, and add them up, you could realize that this is based on a 3, 4, 5. That this side right here is really just 3 times 100, and that this side here is just really 4 times 100. So this last side would have to be what? Well, it would have to be, it's based on a 3, 4, 5, it has to be 5 times 100, or 500. So you can use this to your advantage instead of squaring really large numbers to think about what the triplet is. Another common triplet is a 5, 12, 13. And this fits nicely as well, because 5 squared plus 12 squared equals 13 squared, right? 25 plus 144 is 169. It's another basic triplet you'll see a lot, so that's another common primitive triplet to recognize. And we can generate an infinite number of these, and I'll talk about how to do that in the next video. But here's a group of triplets below 100. Just to realize there's a bunch of these, and 3, 4, 5, and 5, 12, 13s are great ones to recognize. Alright, hope that helped.